Hey guys, welcome back to our channel Civil Tech. Hope you are doing well. So today we are going to analyze and design continuous beam. So as you can see, here is the problem statement. We are going to select a 3-span continuous beam having the length as shown in the figure, and we are going to study three load cases, that is the point load, uniformly distributed load, and uniformly varying load. So the property of the section used is given below, that is M25 grade concrete. Reinforcement bars will be HYSD for longitudinal, that is HYSD 415, and mild 250 for confinement bars. And the section we are going to use today is of the size 300 mm by 500 mm, and the load condition will be dead load. So let's start. So first of all, click on new model. Here select the units, that is kilonewton meter and degree Celsius, and default material is India, and then click upon beam. So we are going to design a 3-span beam. So here click on number of span and select 3, and don't specify the span length as it is going to be varying for each and every span. So click on use custom grid spacing and locate origin option, and then select edit grid. Here we are going to use the option display grid as spacing, because it will be easy to specify the grid right from the origin point. So the spacing we are going to edit as 6 meter for the first one, the second will be 4, and 5 according to our problem statement, and click upon OK, OK again. So here we get the 2D and 3D version of our beam. According to our problem statement, the middle support for both the span was pinned one. So to change it, first select both the points, go to assign, select joint, click on restraints, and here select the pinned one and click on apply, and then click on OK. So you can see that the joints have now changed to pinned. Now let's define the material we are going to use. So go to define, first of all select materials. Here we'll need to add the new material, that is the steel and concrete. So first select India, select concrete, Indian, and grade as we are going to use M25. Click on OK. Add again, and this time add rebar. The grade will be HYST grade 415, and for confinement bars we are going to use it as mild 250. So now we are done with adding the property. Now let's go and define the section. So we are going to define the frame section, and we'll add new property. So we are going to design the concrete beam of rectangular size. The depth we are going to use here is 0.5 meter, and the width is 0.3 meter. Name it whatever you want, and select the material property as M25, and then click on concrete reinforcement. Here we are going to choose the longitudinal bars as HYST 415 and confinement bars as mild 250. Then click upon beam M3 design only. Here specify the cover for your beam. We are going to specify as at 25 mm from both the sides, and remaining keep it as it is. Click on OK, click on OK again. So now let's assign the beam. So select it, go to assign, frame, section property, and click upon beam and click on apply. So you can see the beam properties have been defined. Now let's assign load on it. To apply load, first select the required beam. So we'll select the beam. Now go to assign. First of all, we'll apply the point load. So go to frame loads and select point load. Here let the general option have the default values, that is load pattern dead, coordinate system global, load direction gravity, and load type force. First click on reset form to default values. That will remove all the previous values. Now here we have two options, that is relative distance from end 1, that is we need to put the ratio of the value according to the distance, or we'll have another option that is absolute distance from end 1. So we'll use absolute distance from end 1 due to simplicity. Here we'll apply the point load at a distance of 2 meter from 1 and the load will be 4 kilonewton. So in this way you have applied the point load. So click on apply and then click on OK. So you can see that 4 kilonewton load has been applied on first span. So now we'll apply the uniformly varying load on the second span. So select the second span. Similarly, go to assign frame loads and this time click upon distributed. So again let all the values be as it is and click on reset from to default values. Here again select absolute distance from end 1. So from end 1 the distance is to be 0 and the load will also be 0, and at the distance of 4 meter the load will be 6 kilonewton meter, and click on apply, click on OK. So here you can see that the load has been changed, the load has been applied, that is the uniformly varying load from 0 to 6. Now you'll be wondering that the point load has been disappeared, but no, it hasn't. According to the software you can only see one kind of load applied at a time. So in case you want to see the point load, so select the option display, go to object load assign and click on frame, dead, apply, OK. So you can see here that the 4 kilonewton load is also visible. So now finally we'll apply the uniformly distributed load. So select the third span, go to assign frame loads distributed, and the load we are going to use is 8 kilonewton meter. And first of all click on reset form to delete values and then go to absolute distance from end 1 and just click 8 kilonewton per meter and then apply and then OK. So now let's run the analysis of this model. So click on analyze, go to run analysis and click on run now. If you haven't saved your file before analysis, please save it. So the results have been displayed. It is written that it is having 0 errors, so click on done. You can see the deformed structure. So to know the bending moment diagram and SFD, click on the option show forces and stresses, select frames cable standards option. Here select whichever parameter we are going to require, that is if we require moment 33, then click on it and click on apply. So here we can see the BMD and you can see the field diagram as well as the show values option. Click on apply. Here you will see the value, that is 16.8 kilonewton meter sagging bending moment and minus 10.58 hogging bending moment and all other values. So in case you want to see it in detail, right click on it. So here you will see all the 4 diagrams, that is the FPD, shear force diagram, bending moment and deflection diagram, and you can slide through it to check the exact value at a particular point. So done. So now we are done with analysis. Now let's run the design. So click on design, go to concrete frame design. First select the view revise preferences. Here select the IS code as IS456-2000, that is the Indian IS code. Click on OK. Go to design again and start the design check. So here the ratios of the stress carrying capacity of the beam has been given, which is less than 1. So our beam is in gray color, that is going to be safe. So now let's check whether the members are passed. So the notification we received is that the members have been passed the test capacity check. You can check the details of each and every beam by right click on it. So you will get the details of the load configuration and the steel required. So in this way we have completed the design and analysis of a continuous beam. I hope you have understood all the concepts, and if you have any doubts, don't hesitate to comment below, and I hope you have liked it. So please subscribe to our channel. We'll be coming up with more videos. Till then, take care. Thank you.